Good morning, children. Today we will study about this chapter 9, that is force and laws of motion. Force and laws of motion. So you are already familiar with what is force. So whenever we want to push any object or pull an object or lift an object, we need to apply some effort, and that effort is actually known as force. So which you have already learned in a lower class. So force. If we want to produce motion in a body already at rest, or if we want to destroy the motion of a moving body, we have to apply an effort known as force in the form of a pull or push. That means a body which is already in motion. So if we want to stop that body, we have to apply some amount of force in order to stop that. And a body which is in rest, if we want to move that body, then also we need to apply some amount of force, some amount of effort, which is known as force. So force can be defined as the pull or push of an object, as you can see in the figure. That is the pull and push of an object. Or force is defined as that of the pull or push which produces or tends to produce, destroys or tends to destroy motion in a body, increases or decreases the speed of the body, or changes its direction of motion. That means these are the effects of force. So if you are asked to write what are the effects of force, then you need to write that a force moves a body which is in rest, and a force stops a body which is in motion. It also increases and decreases the speed of a body. Force increases the speed of a body or decreases the speed of a body, and it also changes the direction of motion. So these are the effects of force. So now let's move to balanced and unbalanced force. So what are balanced force, balanced and unbalanced force? So what are balanced force and what are unbalanced force? When forces of equal magnitude is applied on an object from two opposite sides, the object in rest will not move and it will remain in the same state of rest. Such forces are called balanced force. When an equal amount of force is applied on an object in opposite sides, from the opposite sides, then the object will not move, that it will remain in the same position. As you can see in the picture, some persons are pulling in the rope, and there in the first picture an equal amount of force is applied both in the left hand side and the right hand side, that is 300 Newton. But in the second picture the force is not same. As you can see, a 400 Newton of force is applied in the left hand side and 300 Newton of force is applied in the right hand side. So hence the object will move in the direction where the force is more, that is 400 Newton. The objects will move in that direction. So the first case is the case of balanced force, and the second case is the case of unbalanced force. So therefore it is given the balanced force. When forces of equal magnitude is applied on an object from two opposite sides, the object in rest will not move and it will remain in the same state of rest. Such forces are called balanced force. So here, as you can see in the picture, a box is there and an equal amount of force is applied in opposite directions, that is x and y. So here x is equals to y. So therefore the box will not move, it will remain in the same position. But in case of unbalanced force, when forces of different magnitude is applied on an object from the two opposite sides, the object will start moving in the direction of the greater force. So here this is the box, and we apply a force of x and y in opposite sides in different directions, such that here in case of this diagram, the force y is greater than the force x. So therefore the box will move in this direction, that is the direction of y, because a greater amount of force is applied in this direction. So therefore the box will move in this direction, so that is the right hand side. So the object will start moving in the direction of the greater force. Such forces are called unbalanced force, and it acts in the direction the block moves. So in case of balanced force, there is no movement of the object, and in case of unbalanced force, the object moves in the direction of the greater force. So therefore we can sum up like this. So balanced force, A means acceleration. So you have already learned about the acceleration in the chapter 3. So here, in case of balanced force, the acceleration is 0 because the object is not moving, so therefore the acceleration is 0. But in case of unbalanced force, the acceleration is not 0. The second one is a body at rest remains in rest. So in case of balanced force, a body which is in rest remains in rest, it is not moving. But in case of unbalanced force, speed may increase. So speed may increase because the body starts moving, so therefore the speed may increase. So the third point, a body in motion moves with uniform velocity. A body which is already in motion, it moves with uniform velocity. There is no change in velocity of the object. If we apply balanced force on an object which is already in motion, so it moves with uniform velocity. And the direction of motion may change. But in case of unbalanced forces, the direction of motion may change. So there may be change in the direction of motion. So the next is first law of motion. This first law of motion, as we already know, it is given by Newton, so hence it is also known as Newton's first law of motion. But before Newton gave this first law of motion, this idea is actually given by another one great scientist or physicist known as Galileo Galilei. So he performed one, so he gave this idea based on an experiment that he performed. So we will go through this experiment now. So let's go through this Galilean experiment. For this experiment, we will be needing two inclined plane whose surface is very smooth and a smooth marble. First, suppose the angle of inclination of both the planes are same. If we take the marble, as you can see, if we take the marble and release it from the plane in the left hand side from a height, then it will slide down and finally it will rise up in the plane on the right hand side up to the same level from which the marble is released. The level or the height up to which the marble will travel after it is released from the plane on the right hand side, and the height up to which the marble will go on the plane on the right hand side is same. That height is same in both the case because the angle of inclination is same. Now if the right side plane were ultimately made horizontal, if slowly we go on decreasing the angle of inclination of the plane on the left hand side, on the right hand side, then ultimately the marble will travel higher. That means it will travel further. If we go on decreasing the inclination of the plane on the right hand side, the marble will travel further. And finally, if we go on decreasing, and finally if the angle of inclination is 0, then what will happen? The marble would continue to travel forever, trying to reach the same height that is it was released from. And finally, if there is no inclination, that means the inclination on the right hand side is 0, then the marble will travel forever, so it will not stop. Suppose here we assume that there is no external unbalanced force acting on this marble. If the marble is very smooth or the surface is very smooth, this marble will continue rolling forever, which is not possible in practical case. But if there is no external unbalanced force acting on this marble, so it will continue moving forever, trying to reach the same height that it was released from. So this is the experiment performed by Galileo. So based on this experiment, Newton gave Newton's first law of motion. So the first law of motion, so what is the first law of motion? According to the first law of motion, a body continues in its state of rest or of uniform motion in a straight line unless it is compelled by some external unbalanced force to change that state. As in the Galilean experiment we have seen, unless an external unbalanced force is applied on that marble to stop it, it will not stop, it will continue moving forever. Or in other words, all objects resist a change in their state of motion. So all objects resist a change in their state of motion. That is, there is a tendency in undisturbed objects to stay at rest or to keep moving with the same velocity, is called inertia. So the tendency in undisturbed objects to stay at rest or to keep moving with the same velocity is called inertia. Hence the first law of motion is also known as the law of inertia because it speaks about inertia. So what is inertia? So it is the tendency of the object which is at a rest to remain at the state of rest, or an object which is in motion to remain in the state of motion until and unless an external unbalanced force is applied on it. So this is known as inertia. So we can understand this with an example. Suppose when you are moving inside a vehicle, so when suddenly the brakes are applied, you move forward. Why? Because it is the tendency of your body to move forward because you are in the state of motion. And when suddenly the brakes are applied, at that time also your body is actually tending to move forward because it wants to be in the state of motion. So therefore it moved forward. And when suppose you are sitting inside a vehicle, and suddenly when the vehicle starts, then you are pushed backwards. Why? Because at that time you are in the state of rest, and although the vehicle starts moving, your body wants to be or tends to be in the state of rest. So therefore when the vehicle suddenly starts moving, your body is pushed backward as it wants or tends to be in the state of rest. So that is known as inertia. So in the first case it is known as the inertia of motion, and the second case, so it is known as the inertia of rest. So that's all for today. The remaining we will discuss in the next class. Thank you.